final component of the first module, let's have a look at some storage services. In this module, we're going to compare two services that sound similar, but have some key differences, and that's S3 and Glacier. And then finally, let's talk about some of the storage that we actually connect to a server, and that's Elastic Block Store, and also something that we call instant storage. But let's get started by looking at S3. S3 is native storage, that you can connect to over the internet. So it's HTTP or HTTPS access. We make a pretty strong claim here. You can store and retrieve any amount of data, anytime, from anywhere on the web. And that it's very highly scalable, reliable, fast, and durable. So we'll look at how we achieve that within our storage solution. Here are some facts for you. You can store an unlimited number of objects in a bucket. Each object can be up to 5 terabytes in size. And typically, if we use what we call S3 standard, you can get 11 nines of durability. That's 99.9 more nines worth of durability. And our availability is 99.99%. So that's a very durable service. And we achieve that because S3 is a regional service. So we distribute your data across multiple locations every time you read and write data from that. You have the choice of how you connect to it, over HTTP or HTTPS. Highly scalable, very fast, and it supports a wide array of different client-side encryption or server-side encryption technologies. So you can make sure that you're both communicating in transit and at rest in a secure way. You can turn on, if you want to, access logs. So we can see who is accessing and what's the utilization of an S3 bucket. And we provide, like all of our services, lots of SDKs that let you integrate S3 directly into your applications. So there's a wide array of use scenarios, whether it's from storing backups or application files. Maybe a very popular solution today, and we'll talk about this at length, is how we can use S3 to offload work. So this is what we would reference as media hosting. Maybe you want to deliver software, or just use it as a repository to store custom versions of your EC2 operating systems and backups of various things. So let's have a look at some simple concepts around S3. We have the reference of what we call a bucket, and then we talk about putting an object into that bucket. So we like this concept of an object because an object isn't just a file, it's the file and some metadata that describes that file. You can have multiple buckets in an account. We have a soft limit, which is 100 buckets. That means, a soft limit means that you can talk or raise a ticket and increase that number of buckets. And then finally, and very important, you control who has access and permissions to carry out operations inside of that bucket. So when you create a bucket, the only person that has access to that bucket is you, the person that created it. Now, actually, behind the scenes, it's also the owner of the AWS root account on that account that contains the bucket. So you always want to bear that in mind as well. Now, when we put objects in that bucket, the bucket must be globally unique, so no other AWS customer in the world can have the same named bucket. And then your objects that you put in that also have what we call an object key. That's a unique identifier for the object that you're putting in that bucket. We configure the security around those buckets with a number of different processes. Either what we call an access control list, or more preferably with what we call bucket policies or identity access management policies. The policies allow us much more granular control over a wide variety of permissions that we want to assign to different users. You can then upload, download data, or put and get data to S3 via our endpoint services, including SSL TLS endpoints, and you can optionally choose to have data encrypted by S3 as you put data in there. S3 also supports something called versioning. This is off by default, but you can turn this on if you need it. What this means is, if I have an object called photo1.gif in a bucket, and then I upload a new object that has the same name, photo1.gif, it doesn't overwrite the existing one, but instead it hides it away and puts a marker in front of it. So we know it's there, It has a hide marker in front of it, but we don't overwrite it. Now, don't forget you're going to pay for every object, whether it's hidden or not, inside of your bucket. So versioning could have a cost impact. You can then easily go back to the console and roll back to previous versions of similarly named or same named objects. There are three states of an Amazon S3 bucket. The unversioned bucket that we start with, or a bucket that has versioning enabled, or we can suspend versioning if at some stage we find it not useful for us. So three different states. Now, if you want to, we can enable what we call an S3 object lifecycle. Lifecycle requires that we do have versioning turned on, but now what I can do is make use of the many different versions of S3. We have two, which is S3 standard and S3 infrequent access. Or I could even take advantage of Glacier as well. And when I put an object in S3, I could say, keep it here for 30 days. After 30 days, move it into S3 infrequent access. It's a lower cost place to store data, but I have lower availability of access to it. Maybe I keep that data for 60 days in S3 infrequent access, and then the lifecycle policy has a rule that moves it to Glacier. That's our lowest cost of storage. And we keep it in Glacier for 1 year, and then we have a lifecycle policy that deletes that data. So this is a very useful way of automatically aging data that we want to keep through different services, reducing the cost of storing that data over time. So it's a very important service and worth a look at. S3 pricing. Pay for what you use. You don't have to pre-provision. You don't have to tell AWS, I need this amount of data or this amount of space in the future. You just think of S3 as a virtually unlimited amount of storage. You keep putting data in, and we charge you for the data that you currently have. Take data out, stop paying for it. There's no minimum fee. And pricing is based on the region where you create your S3 bucket. I always like to encourage customers to use our AWS Simple Monthly Calculator. This is an online web calculator. You'll find this on our website, that allows you to model not just the storage or the volume of data, but how you interact with that data. And I encourage you to think that there's more to just volume. So if you want to store 100 gig, you can put that in and you'll get a price. But how do you get that data, read and write that data, and where do you move that data in and out from? Model the whole how your application works and get the true pricing. After S3, let's talk about Glacier. And Glacier, we term that enterprise archival. So it's long-term, low-cost archiving environment. We tend to put data in there that we have to store, maybe for some legal or compliance reason, but we hope we probably don't have to retrieve it too often. It has the same durability as S3, but you see there 3 to 5 hours retrieval time. So when you want to get data out of S3, you have to put a request in, wait 3 to 5 hours, and then we'll make an endpoint available where you can now download that data from. But the good news, it's our lowest cost of storage. So from approximately 1 cent per gig, it depends on the region that you're storing that data. So we have all of these different classes that we've talked about: S3 Standard, S3 Infrequent Access, and Glacier. And we want to think carefully about which is the right place to store our data based on the time, the availability that we need, and the frequency that we're going to access it. Moving on from Glacier, we also have Amazon Elastic Block Store, EBS. This is a persistent block level storage, and it's an availability zone service. Whenever I say that to you, I want you to start to think availability zone service means that you, the architect, we're going to take on some additional responsibility for how we make that durable. But if you do a snapshot, that's a feature within the console or command line, that data is going to be made or stored in S3. So there are some processes that you can go through, to improve that single availability zone. When we say EBS, you can think of that as a networked attached hard drive, a drive that we connect to your EC2 servers. So when we look at the life cycle of an EBS volume, we have a huge amount of unused space available for you, the customer, to come to and create a new hard drive, a new EBS volume. You can choose anything from 1 to 16 terabytes in size, 1 gig to 16 terabytes in size, and create a volume. Once you've created that volume, let's attach it to an EC2, and then let's format it or get it ready to use, mount that into the operating system. We can then use it for our normal day-to-day operation on that server. But when we've finished with it, maybe we want to create a snapshot, so we've got a backup, and then we can detach the EBS from the EC2, and eventually we can delete it. Nice to do the deletion, because we stop paying for that EBS drive. So that's the life cycle of an EBS volume, or network attached hard drive that we connect to those EC2 instances. There are quite a few different types of EBSs, and really our choice is all about picking the right one with the right performance characteristics to give my application server the oomph it needs to be successful. So we support primarily two types, SSD drive and hard drive backed volumes. SSD drives, we call those GP2 or provisioned IOPS. They both support a different amount of input-output operations per second. You pick the right one for your workload. We also have hard drive backed volumes, which are optimized for different workloads, maybe large streaming, or high throughput in terms of megabits per second. Again, we have a nice chart that you can see, depending upon the performance characteristics you need from your application, we're going to choose the right drive to give you that. Now, the good news here, again, we can think about the word resize. Even if we make the right or the wrong choice at the beginning, we can fix that problem later on. I can create a snapshot, and I can roll that snapshot onto a different type of drive later on. So maybe I picked a drive that I was paying too much for. I didn't need that performance. I can downsize or, come to a lower provisioned amount of input-output operations. This is another good practice that we're going to encourage you to take. So some facts about EBS. We recommend it when you have to access data and you need that long-term persistence. You're going to use it to launch your servers, and you have the choice whether you want that EBS volume to be encrypted. And then finally, not just a fact, but an essential component of what you're going to do, periodically, you're going to take snapshots to make sure that you have some recoverability if there's any eventual failures. So use cases. Well, it's quite straightforward, isn't it? We're going to use that EBS as we would a hard drive. So we're going to attach one to act as our root or boot volume for our EC2 instances. But, if I'm using an EBS maybe for a different type of application, well, I create it in the same way, but I pay a lot more attention to the performance characteristics of the application that I'm creating. Pricing is a little bit different from what we talked about with S3. Here, when I create an EBS drive, I pay for what I provision. So if I create a 16 terabyte EBS volume, I'm paying for the whole 16 terabytes, whether I put 1 byte of data in or the full 16 terabytes. So we pay for what we provision. And again, like most of our services, pricing is regional, and you can again play with our online simple monthly calculator to look at some of these cost options. We do some protection of those EBS drives. We don't want to have any risk of a single equipment failure in an availability zone affecting your EBS drives. So this is information for you to know, but not for you to act on. Behind the scenes, we are replicating your data across multiple storage devices within a single AZ. You should still be taking advantage of all of the recoverability options and high availability options that we give you by building your solutions over multi-AZs. So this is just what we do in the background. So when we compare EBS and S3, I think it's quite simple to see, where we're going to use one over the other. Block store tells me that I can make a change to a single block in a large file. If I use that in EBS, I can do that. But in S3, I can't. I would have to make that change and then re-upload the whole object again to S3. They're both very high performance, but EBS is very high IOPS, and that's the right one to use as a hard drive for a server. Redundancy. S3, across multiple regions, it's a regional service. EBS, it's an availability zone service, so you take on those responsibility. They both support multiple different encryption types and the typical use cases you can see described. It's a hard drive or it's online native online native storage. The final storage solution I want to talk about has some similarities to EBS drives. In this case, it's called Amazon EC2 Instant Storage. It has some significant differences to EBS though as well. and we need to be aware of those. We reference this as local, complementary, direct attached block storage. So what do those first two words mean? Local. Well, we say local because there are hard drives in the hypervisor or the EC2 host where you run your server. And so that means the drive is physically connected to your EC2. Complementary, well, that's good news. That means it's free. We don't charge you for this storage. But the very important phrase is actually towards the bottom of this list, where we can see it says, has no persistence. So what's the impact of that? What that means is, if I stop that EC2 server, all of that data has gone. So I'm not going to use this drive to store my customer-sensitive, very highly important data, but this could be very useful for me to use as a way to accelerate my application. And the reason we can use it to accelerate is further up the list, you can see it says up to 365,000 read IOPS. So incredibly high performance drive. And that's because of the locality. It's in the same hypervisor as your EC2 instance. So let's use instant storage. It's free, it's super fast, but let's pay attention to the fact that it has no persistence. So we're not going to store our sensitive data on it. So there are the two differences, and we use the word ephemeral, which is an indication that it's temporary data. And finally, let's go through the process of looking at, kind of like the full life cycle of an EC2. The boot, the reboot, stop, and the terminate process. In the left-hand column, you'll see we have a number of characteristics of that EC2. It has IP addressing, it has instant store, it has EBS volumes, and then finally at the bottom row, how do we charge for it? So let's say we reboot that EC2 instance, and what do some of those things happen, or what changes? So we can see here, if I reboot a machine, there's very little differences that appear as I look down through the list. Most of my data is preserved, the billing hour doesn't change, the IP addressing doesn't change. But if we come to the middle column, we can start to see some interesting things change. If I stop the server, I can see that my public IP address will get reassigned. I will get a new public IP address. But if I've used an EIP, I'm still good. That's going to be fixed and associated with that machine. If I stop the EC2, the instant store data will get erased. But my EBS volume is preserved. But here's some good news. If I stop it, then I stop paying for it. So this is a very important chart to look at all of the different life cycles of an EC2 and what are some of the things that might change as you go through that. So in review, we talked about compute service using EC2s. We covered things from purchasing models to the different types or the different families that we have. We had an introduction to virtual private clouds and some of the little components that we can add to virtual private clouds to configure how they work. And then we finished in this module by talking about some of our storage solutions. As we go through the course, we will have a deeper look at some of all of these components. Now, please take the time to finish your knowledge assessment, and let's complete this module by doing a quick knowledge check, just to make sure we were all paying attention. So, what AWS service would help support your web application to offload serving static assets and store user-uploaded images and video off the instance? Now, we talked about quite a few different storage solutions. We talked about EBS and Instant Store and Glacier, but I think in this case, that must be a reference to S3. The next question, how would an EC2 instance find its private and public IP address? And you remember we had those two services, they sounded similar, user data and metadata, but it was the metadata service that retained this information that we could get from. And then a security question, what acts as an additional layer of security at the subnet level? Now, at the instance, EC2 instance, we had a security group. At the subnet, we had a network access control list. And then the final question, true or false? We limit the amount of data that you can store in S3, and we know that that's not true. So we've got a final lab as part of this module, working with EBS drives. Up next, we have the last lab for this module, working with EBS drives. So we have the lab, And then coming up in the next module, we have a very important session on AWS security, identity, and access management.